Preparing for a principal engineering at Wells Fargo interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a secure, scalable Java platform for GenAI applications in a large bank? I would begin with a platform, not isolated prototypes. Java services would expose governed APIs for model access, prompt templates, retrieval, audit logging, and policy enforcement. I would separate customer, employee, and operational data domains, encrypt data end-to-end, and apply least privilege identity. Kubernetes, centralized observability, circuit breakers, and automated compliance checks support resilience. Model routing and quotas control cost. At principal level, I would publish reusable standards while allowing teams flexibility inside those guardrails. While answering, cover domain boundaries, API governance, multi-tenancy, data classification, zero trust security, observability, resiliency, deployment standards, and how you would balance innovation with regulatory controls. Question 2. Which Java features and design patterns are most important for building high-throughput banking services? For high-throughput services, I favor immutable records for messages, interfaces for replaceable dependencies, and explicit error models rather than broad catches. Java virtual threads can simplify highly concurrent I/O workloads, but I would verify driver and downstream behavior first. Completable future or structured concurrency helps coordinate independent calls. I use bounded pools, timeouts, and bulkheads to prevent resource exhaustion. Spring Boot accelerates delivery, while profiling, allocation analysis, and load testing determine whether optimizations are actually justified. Make sure to cover immutability, records, generics, concurrency utilities, virtual threads where appropriate, dependency injection, clean architecture, exception handling, garbage collection, and measurable performance trade-offs. Question 3. How would you make a Java payment or account service resilient to partial failures? The engineering problem is preventing one dependency failure from becoming a banking outage or duplicate transaction. I would set strict timeouts, use bounded retries with exponential backoff and jitter, and isolate calls with bulkheads and circuit breakers. Every command would carry an idempotency key, with durable status tracking and reconciliation for uncertain outcomes. For asynchronous work, an outbox publishes events reliably. I would expose honest pending or declined states rather than pretending a failed downstream operation succeeded. In your answer, talk about timeouts, retries with jitter, idempotency, circuit breakers, bulkheads, transactional boundaries, fallbacks, durable messaging, reconciliation, and clear customer visible failure semantics. Question 4. How would you use Spring Boot and Java to expose a governed GenAI service? I would create a versioned Spring Boot API that accepts a use case identifier rather than arbitrary model instructions. The service authenticates callers, authorizes data access, validates payloads, applies prompt and content policies, and routes requests through an abstract provider interface. Rate limits and budgets protect shared capacity. Each request receives a correlation ID and produces auditable metadata without storing sensitive prompts unnecessarily. This design lets Wells Fargo change models or vendors without forcing every consuming application to rewrite. Be sure to mention API versioning, authentication, authorization, request validation, prompt and model policies, rate limiting, tenant isolation, tracing, audit records, and provider abstraction. Question 5. How would you design a retrieval-augmented generation system for internal banking knowledge? I would ingest approved documents through a pipeline that preserves ownership, classification, effective dates, and access control metadata. Chunking should respect headings and policy boundaries, while hybrid keyword and vector search improves precision. At query time, authorization filters must run before generation, not after it. The prompt should require citations and explicitly allow an insufficient information response. I would monitor retrieval recall, groundedness, freshness, and user feedback, then re-index when source policies change. Focus on ingestion pipelines, document permissions, chunking, embeddings, hybrid search, metadata filters, freshness, citation quality, prompt construction, and preventing retrieval from bypassing authorization. Question 6. How would you evaluate and control hallucinations in a banking GenAI application? I would define a golden evaluation set from representative, approved banking scenarios and measure answer correctness, citation support, refusal behavior, latency, and cost. Automated checks can compare claims with retrieved evidence, while subject matter experts review high-risk cases. The application should abstain when evidence is missing, validate structured outputs, and restrict actions to deterministic services. Red team tests would target prompt injection and sensitive data leakage. Every model, prompt, and retrieval change requires regression evaluation before production release. In your answer, cover groundedness, factual accuracy, adversarial testing, golden datasets, human review, confidence thresholds, abstention, output validation, monitoring, and model or prompt regression testing. Question 7. How would you secure a GenAI solution handling sensitive customer or financial information? I would minimize data first, tokenize identifiers where possible, and keep sensitive processing inside approved private infrastructure. Encryption, managed identities, least privilege, network isolation, DLP scanning, and short retention periods are baseline controls. Prompts and retrieved content must be treated as untrusted input because prompt injection can manipulate tools or expose data. Vendors require contractual and technical review, including training use restrictions. High-impact decisions remain human-approved, with complete audit trails and reproducible evidence. Mention data minimization, tokenization, encryption, private networking, identity controls, retention limits, prompt injection defenses, vendor governance, DLP, auditability, and human approval for consequential actions. Question 8. How would you design an enterprise GenAI agent without allowing it to take unsafe actions? I would keep the language model responsible for interpretation and planning, never for final authorization. Each tool would have a narrow schema, explicit scopes, transaction limits, and deterministic validation implemented in Java services. Sensitive actions require user confirmation or human approval, while read-only actions can be more automated. The agent runs in a constrained environment with timeouts, quotas, and complete tool call auditing. Idempotency protects retries. This separation preserves conversational flexibility without delegating banking control to probabilistic output. Make sure to cover bounded tools, explicit authorization, policy enforcement, confirmation steps, sandboxing, transaction limits, idempotency, audit logs, human escalation, and deterministic business services. Question 9. When is blockchain appropriate for a Wells Fargo business problem, and when is it not? Blockchain is appropriate when multiple organizations need a shared, tamper-evident record but do not want one participant controlling reconciliation. Examples could include selected trade finance or asset provenance workflows. It is not justified merely because records are immutable. A governed relational database is usually faster, cheaper, and easier to operate. I would evaluate participant incentives, privacy, throughput, settlement finality, regulatory obligations, and integration complexity. A successful proposal must quantify reduced reconciliation or settlement friction, not just demonstrate distributed ledger technology. Discuss shared ownership, multi-party trust, tamper evidence, reconciliation costs, throughput, privacy, governance, legal enforceability, simpler database alternatives, and measurable business value. Question 10. How would you architect a permissioned blockchain solution for financial institutions? I would use a permissioned network with institution identities issued by governed certificate authorities and hardware-backed key protection. Smart contracts enforce shared workflow rules, while endorsement policies require the appropriate parties to approve state changes. Sensitive details should use private data mechanisms or remain off-chain, with hashes anchoring integrity. Consensus must provide predictable finality and meet performance needs. Java adapters would expose stable APIs to core systems, while governance defines onboarding, upgrades, dispute handling, and node responsibilities. Cover membership identity, certificate authorities, endorsement policies, consensus, channels or private data, smart contracts, ledger storage, key custody, governance, observability, and off-chain integration. Question 11. What are the main risks of smart contracts in a regulated banking environment? A smart contract can encode a defect into a shared process, and immutability makes correction difficult. I would minimize contract complexity, use strict authorization and state transition rules, and test with unit, property-based, integration, and adversarial scenarios. External facts require trusted oracles with validation and fallback procedures. Upgradability must be governed, versioned, and transparent rather than hidden. Emergency pause controls may be appropriate, but they need documented authority and auditability. Legal and operational ownership must accompany technical correctness. In your answer, mention immutable defects, authorization errors, reentrancy where relevant, Oracle trust, upgradability, formal testing, privacy, legal interpretation, emergency controls, and auditable version governance. Question 12. How would you choose a consensus mechanism for a permissioned financial blockchain? I would start by identifying the failure model and business requirement. If known institutions participate and the primary concern is crash failure, a practical Byzantine or crash fault-tolerant protocol may provide fast deterministic finality. I would compare latency, throughput, quorum behavior, recovery, and node management complexity under realistic workloads. Proof of work would rarely fit a permissioned banking network because it adds energy cost without useful trust benefits. The final choice must be tested with failure injection and approved governance controls. Be sure to discuss fault assumptions, crash versus Byzantine failures, finality, latency, throughput, membership size, operational complexity, energy usage, and regulatory expectations. Question 13. How would you integrate a blockchain network with existing Java-based core banking systems? I would isolate ledger-specific details behind an anti-corruption layer and expose business-level APIs to core systems. Java services translate canonical banking events into blockchain transactions, persist correlation and ID impotency records, and publish status changes through a durable event bus. Because cross-system atomicity is unrealistic, workflows use explicit pending states, retries, and reconciliation. I would avoid placing sensitive customer data directly on-chain. Contract versions, key management, observability, and operational runbooks are part of the integration design. Focus on anti-corruption layers, canonical data models, event-driven integration, ID impotency, transaction boundaries, eventual consistency, reconciliation, security, and avoiding direct coupling to ledger internals. Question 14. How would you design an event-driven Java architecture for GenAI and blockchain workflows? I would define versioned domain events with stable business identifiers and minimal sensitive content. Producers use an outbox so database state and event publication cannot silently diverge. Kafka-style partitioning preserves ordering where needed, while consumers remain idempotent because delivery is commonly at least once. Dead letter queues, replay tooling, correlation IDs, and distributed tracing support operations. GenAI outputs would be events only after policy validation, and blockchain confirmations would update workflow state rather than blocking unrelated transactions. Discuss event schemas, schema evolution, ordering, delivery guarantees, outbox pattern, partitioning, dead letter handling, replay, trace propagation, idempotent consumers, and sensitive data controls. Question 15. How would you establish data governance for AI and blockchain systems in a bank? I would create a data inventory linking sources, owners, classifications, purposes, retention rules, and downstream consumers. Training and retrieval datasets require provenance, quality checks, access reviews, and documented permitted use. Blockchain needs special scrutiny because immutable records may conflict with correction or deletion obligations, Sensitive data should remain off-chain, with carefully governed references. Automated policy controls provide evidence, but named data stewards remain accountable. I would involve legal, privacy, security, and compliance teams before production decisions. Mention data lineage, classification, consent, retention, access reviews, model training provenance, immutable record limitations, deletion requirements, stewardship, audit evidence, and regulatory collaboration. Question 16. How would you modernize a legacy Java banking platform while introducing GenAI or blockchain capabilities? I would avoid a big bang rewrite. First, establish APIs and observability around the legacy capability, then identify a bounded domain suitable for incremental extraction. A strangler facade routes selected traffic to new Java services while contract tests protect existing behavior. Events synchronize state, and reconciliation detects drift during coexistence. GenAI or blockchain is introduced only where it solves a measured problem. Each migration slice needs rollback, security review, operational ownership, and success metrics such as reduced latency or reconciliation effort. In your answer, cover strangler patterns, domain decomposition, API facades, coexistence, incremental migration, contract testing, observability, rollback, data synchronization, and measurable business outcomes. Question 17. How do you influence architecture across teams as a principal engineer at a large financial institution? I influence through clarity and evidence rather than title. I write concise architecture decisions, explain trade-offs in business terms, and validate risky assumptions with small prototypes. Standards should provide paved roads, including secure Java libraries, deployment templates, and observability defaults, while exceptions have an explicit review path. I involve product, security, operations, and compliance early, then coach teams through adoption. I measure outcomes such as reliability, delivery speed, and control coverage, not merely document completion. Be sure to discuss technical vision, written architecture decisions, stakeholder alignment, prototypes, standards, exceptions, mentoring, governance forums, delivery empathy, and measuring adoption rather than imposing mandates. Question 18. Describe how you would handle a production incident involving a GenAI service or blockchain transaction flow. My first priority is protecting customers and preserving transaction integrity. I would establish incident command, assess blast radius, disable unsafe AI actions or pause affected workflows, and communicate clearly with stakeholders. Logs, prompts, model versions, ledger states, and deployment artifacts must be preserved for investigation. For uncertain transactions, reconciliation determines the authoritative outcome before retries. After recovery, I would conduct a blameless analysis, address control gaps, improve tests and runbooks, and verify remediation through a follow-up review. Focus on customer protection, incident command, containment, evidence preservation, communication, rollback or feature disablement, reconciliation, root cause analysis, and durable corrective actions. Question 19. How would you optimize performance and cost for Java-based GenAI and blockchain workloads? I would establish service-level objectives and measure end-to-end latency, throughput, error rates, token usage, and ledger commit time before optimizing. Java profiling may reveal allocation, blocking, or inefficient serialization issues. Bounded concurrency and connection pool tuning often matter more than micro-optimizations. For GenAI, routing simple requests to smaller models, caching safe results, shortening context, and batching embeddings reduce cost. Blockchain workloads benefit from appropriate batching and storage design. I would optimize against business quality, not latency alone. Cover workload measurement, latency budgets, profiling, caching, batching, asynchronous processing, model selection, token control, connection pools, ledger sizing, capacity planning, and cost-quality trade-offs. Question 20. How would you create a 3-year technology roadmap for Java, GenAI, and blockchain capabilities at Wells Fargo? I would begin with business problems, regulatory constraints, and capability gaps rather than selecting technologies first. Year 1 would establish secure Java platform standards, data foundations, observability, model governance, and focused proofs of value. Year 2 would scale validated GenAI products and selected shared ledger workflows with measurable adoption and control evidence. Year 3 would optimize economics and ecosystem integration. Each initiative needs an accountable owner, architecture runway, milestone metrics, dependency map, and explicit stop criteria if benefits or risk assumptions fail. Mention business outcomes, risk-based prioritization, platform foundations, talent, experimentation, governance, architecture runway, measurable milestones, dependency management, funding, and stopping initiatives that lack evidence. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.